mathematicians. Believe it or not, this is my third attempt at this video. My computer keeps refusing to process it, so I'm going to try to keep it around 10 minutes or so and then just keep breaking it up because I think my last one was too big. So 2.5, this is the end of 2.5, so this is the second video, and we're going to talk a little bit about end behavior. And when we're talking about end behavior, what we mean is what happens to the function of interest as x approaches positive or negative infinity. All right, so if we just look at a friendly example, f of x equals x squared, and we ask ourselves what happens to this function as we travel down this road forever, right? And so we'd say the limit as x approaches infinity of x squared equals infinity, right? Clearly we plug this in here, we get infinity squared. It goes to infinity on this side, up forever, right? We look at another function. Our good friend f of x equals 1 over x. What is its end behavior? The limit as x approaches infinity of 1 over x equals 0, right? As x approaches infinity, y approaches 0, right? That's what's going on here. So there's some rules that I'm going to go over that are just going to help us. So suppose we have f of x equals p of x over q of x, where p and q are polynomials. So we have our just friendly rational expression here, right? Fraction with polynomials. And our p of x, we're going to use the same expression we talked about the last video to represent our polynomial. And all that's happening here is that you have your leading term, and then each subsequent term is 1 degree lower, right? So we start with m, then we have m minus 1, m minus 2, dot, 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 depending on where we start with m. And eventually you'll have your x squared, your x to the 1, and then your constant term. Likewise, with your q of x, we are just changing the notation to differentiate between the two. And so here the leading coefficient is m, here the leading coefficient is a to the m, the leading coefficient is b to the m, the leading term has power m, the leading term here has power n. Okay? So again, when you're asked about end behavior, you're being asked about what happens to the function of interest as x approaches infinity. Okay, so we're looking at the limit of that function as x approaches infinity. So we're going to have 4 rules we're going to look at here. First is the case where m is less than n. That means the degree of numerator is less than the degree of the denominator. Okay, and so when that happens, the limit as x approaches infinity, positive or negative infinity, it doesn't matter, of the function is going to equal 0. Okay, and if we think about what's happening there, we have a fraction, and we have x to the m on top, x to the n on bottom, and this n is larger than this m, right? So this is going to grow faster. It will grow faster. Another way to think about it is all of these are going to cancel out, and you're going to be left with somebody down there, and so that's going to go to 0. All right? The second situation is going to be where m equals n. Otherwise, the degree of numerator equals the degree of the denominator. And so then your limit as x approaches positive or negative infinity of that f of x is going to be your a to the m over your b to the n. Oh, up here, I forgot to include our horizontal asymptote. So wherever this limit is going, we're getting closer and closer and closer to 1, but we're never going to touch it. That means our y equals 0 is the HA, or the horizontal asymptote. Okay? So down here, y equals a to the m over b to the n is the horizontal asymptote. Part C, we have the situation where m is greater than n. So degree of numerator is greater than okay, and so the limit, and so if you think about what's going to happen here, again, you're going to have more infinities on the top than on the bottom, right? So the limit here is going to be infinity and no horizontal asymptote. Okay. Now let's talk about one more situation, one more rule I want to include, and it's a special situation of C. Okay, so we still have m greater than n, but m equals n plus 1, or the degree of m is 1 more than the degree of n, right? So the top is 1 more than the degree of n. Still, all of these things are true. Your limit of f of x as x goes to positive or negative infinity is still infinity, and there's no horizontal asymptote, but there is a slant asymptote. Okay, so this is the slant asymptote situation. I'm going to go ahead and stop this video, okay, and then we're going to practice using our rules here.